We are back with the topic of swipeable screens because last time I feel like we just did not do a good enough job creating a swipeable change scenes. Realistically, if you're swiping to change scenes for your project, let's say you want to have a shop window and you want to have an upgrade window and you want to have like a game window, you know, that's all good and fun to be able to swipe and change scenes, but it is a little bit slower and you can lose some unsaved data if you didn't code it as well as you should have. So there's a better way to handle this issue, and it actually reduces delay for the player because there are no load times. Everything will load at the same time. And then it also makes it a little bit intuitive and just a little better looking overall. So I'm going to show you what I have here, what you're going to be able to do by the end of the video, and that is create a swipeable multi-scene scene. So let's just go ahead and click play. Now I'm using a mouse, so there is slightly different coding for a mouse as there is for a touch, but the method is the same. So we want to be able to, drag and then find a new scene. Okay, and then you'll probably notice that while I am dragging, the movement is very smooth, so we can change from one scene to the next. And then if, let's say I end in between two scenes, I want my camera to center on the closest scene, whichever one I have. So if I'm slightly off center, it's going to choose the one that, like in this case, it would be orange. In that case, it would be purple. So let me just put it at the middle and see what it picks. So it picked purple. Must have been closer to the purple side. And if, no matter where I put it, it's going to find the closest scene that we're in, and it's going to put us there. Now, I didn't do the extra coding for like what happens if we go off screen, but that would be easy to add. You just have to add a boundary. Now, I've put on this scene some buttons, so it'll just count how many times have I clicked it. Those are very simple buttons. Not that important, and of course you wouldn't need them in your game, but I will be showing you how to create UI elements that move when you go from scene to scene, and the trick to it is they actually don't move, so we'll go over all of that. Let's start with the buttons, because if you're going to make multiple scenes within one scene, you obviously want to have your UI changing for each one of these scenes. And normally the UI will find its place where, respective to the camera, so it'll always be in this corner or that corner or wherever you place it. What I'm doing instead is I'm actually going to create a plane as a background and then put a canvas on that plane as the same size as the plane, and then put some UI on that canvas which is located at the plane. So basically I'm telling the canvas to have world space. Alright, so let's go over that real quickly, go to the scene, show you what the scene looks like. I have 1, 2, 3, 4, 5, 6 planes, and each plane represents a scene, so I've labeled them with different colors. In my materials I got like blue, gray, green, orange, purple, red, and then since each plane is a different color, we'll use that to represent a scene. Now each of these planes has a specific length, so if I go to my planes, not this one is the gray plane, so that one's going to have like a really long length and a bigger Z value, but all the rest of my planes, they are located at their respective places, and their scale is 111, which means 10 units by 10 units. So that this one is 20 units offset from the middle. This one is at 0, 0, 0. This one's at -10. Sorry, it took the canvas. So let me click on the plane. That one's at -10. I click on plane 4, it's +10, and plane 5, +20. So that part's easy. Now what do we do to get the UI on these planes instead of just on the screen and have it being stuck there? Two things. First of all, we want to create a canvas. Now it's not going to be the main canvas. It could be the main canvas, but you need to create a canvas, and we're going to need to modify some of the settings. So normally your canvas will have in its render mode screen space overlay, which means no matter which direction you're looking or where the camera is located, you'll always see the things in the same place. You want to change that to world space because we're going to be placing these canvases in the world on each plane. So on plane 1, I have a canvas. I've made the canvas a child of the plane. So to show you how to do that, it's really simple. You're just going to take the canvas and then drag it over the plane, and it'll automatically become a child. And what that means is it's going to take the position data of that plane. So now my canvas is a child of the plane. I've rendered it in world space, and I want to make sure that my position is zeroed out so that it'll actually be on the plane at all times. And I want to set my width and my height to very specific values. I want it to be 1000 by 1000. Now the reason why I chose those two numbers is because my plane is currently a square. If you're building this for a mobile platform, which is highly likely, then you're going to want to use a different ratio. For example, for iPhone, where you have a width of 900 and a height of 1600, or in other words, this 9 to 16 ratio, you would make your width 900 and 1600 respectively. Now, you need to have these high numbers because that's going to make your text appear normally. I'll show you what happens when I use lower numbers and a scale of 1. So I'm just going to do that really quickly. Right now, I have a width of 1000, height of 1000, and my scale is 0.01, or in other words, move the decimal 2 times, right? So that would be a total of width of 10 and a height of 10, which is exactly the same size as the plane. If I go to, let's just do this really quickly, scale of 1, 1, and then width of 10, height of 10. So now I have my plane, right? For that particular plane at least. It doesn't seem to update. Just take a look at the button, which by the way has a width and a height of 300. That button looks nice and big, but if I want it to fit on the plane, it would be like a width of 3 and a height of 3. And then let's scroll back in, and you'll see the button there. Let's go to the game view and then play and drag you over so you can see it. So the button looks really weird, and like you don't see any of the text. The text is actually showing up right over here, which is that big giant black area. That's the text. So it looks all messed up when you don't use a proper width and height. So we're going to change that back, make that 300 again. Okay, and then we're going to go to the canvas, make that 1000. And then 0.01 for the scale. And that is important. And now if I click play again, take a look at the blue screen, back to normal. Oh, it looks like one of our values didn't save, so let's just fix that real quick. That looks good. Go back to the button. Oh, 30. No, we want 300. Okay. So now everything is saved. So again, back to our canvas. We've taken a canvas, made a child of the plane, set up the width and height accordingly, make sure it matches up with the size of your plane. You can always just check in the scene view and make sure that they're the same size. Then I threw on a button because I just wanted to test and see if things are different, so I'll show you what that means. I can click, it'll count the number of clicks, and then if I go to my orange scene, you know, it's a different button and it has different variables. So in other words, these are completely different scenes in terms of their function. Okay, so I use buttons. This part, not really necessary. If you want to try the button, just so you can test it out and see if your scenes are different and your canvases are working and all that, we'll go over the script real quick. So I'm just going to bring that in. This is the clicked script, and the clicked script was attached to each of these buttons, and then on the button, you'll notice right over here in the inspector that I chose the game object it was attached to, and then I went into the script and I found click. So let's go to the script, look at it real quick. I created a text, a string, and an integer. Those are my 3 variables. And then in the start function, the text is the game object. I get component in children text. So you'll notice the button has the script on it down here. And the text is a child of the button. So I'm going to be getting the text component from the child. Now clicked, that is my string. It's just going to say clicked. That totally unnecessary, but I just created it in case you wanted to have a string saved as whatever kind of statement you want to make. And then button text.text equals clicked plus count plus times. So that's pretty straightforward. I'm going to take, it's going to say clicked, and then the number, and then times. So clicked 5 times, clicked 6 times, clicked 7 times, etc. Now, this is in the start menu, so it's going to say 0 every time because count is currently 0. And then every time they click, I want to call that function. So every time they click, this will happen. So it will increase count by 1, and then it'll update the text. Okay, make sure you update the text. Sometimes you forget that, and then it doesn't show you the new number. So that's all it was. Very simple script. Let's get to the actual swiping. So here's what the swipe script looks like. It's total of 70 some lines. Some of them are spaces. Anyway, Again, I made the text nice and large, so hopefully it's easy enough to read. We're going to create a few vector 3s. So I created a first, a last, a swipe, and a camera start point. And the method I chose to use is I want to actually move the camera instead of moving the planes. It's much easier to have everything sitting here in its fixed position and just move the camera so it looks like the screen is moving even though it's actually the camera that is moving. Having a solid color background helps create that illusion that everything below is moving. You'll notice, just take a look, I swipe and everything moves. It kind of seems like I'm dragging it, but really I'm not dragging it, I'm just moving the camera the opposite way. So in my script I want to do that as well. So first thing I need to do is of course figure out where is the camera, and then where are all the planes, and you know, if I want to do some kind of like minimum distance, then what will that be? So this float distance, this is more for if you want to calculate if they're actually swiping. What I realized while I was developing this is if I actually use a minimum distance to calculate a swipe, then the movement is very choppy and it doesn't look very good. So a better way to swipe and change scenes is ignore this entirely. So I can even comment that out. I'm not going to because I don't want to create any errors on accident, but you just ignore that entirely. So first off, let's get our camera starting point. So to find the camera start point, which is a vector 3, I'm just going to find my main camera transform position. So before I can do that, I need to identify what is my main camera. So main camera equals camera.main.gameObject. Very simple. Okay, so now I have my starting point's position, and I want to save that variable and not do anything to it because I'm going to use that in calculations later on. Now I also need to find all of my planes. So what I've done to make that very convenient, because Unity has this feature where you can just make it a child of an empty. Empty is called plane, so notice it's not an actual plane, it's just an empty. And if all of these are children of that empty, then I can access all of them at once in a script. So this part is pretty cool. In one line, I'm going to say planes equals gameObject dot find planes dot get components in children transform. Now what that's going to do is it's actually going to get all the transform components, because planes is not just one variable, it's an array. It's an array of transforms. For those of you who don't know what an array is a collection of multiple of that variable. So I could have an array of vector 3s, an array of game objects, an array of floats, or an array of transforms. I'm going to do transforms because then I can access everything within it, like the scale, the rotation, the position, etc. So this variable actually represents 5 different transforms, the transform of each of these planes. Okay, so we've got the array. And then what we're going to do next is we are going to start doing some calculations. So everything here is about the swipe. Okay. Now when I'm using a mouse, I'm going to be using the code up top. When I'm using a touchscreen, I'm going to use touches. So it just depends on what I'm using. Now you'll notice up at the top, kind of complex. Let's start with the easy stuff. So if the person presses the mouse button, the left click, then we want to gather that mouse position, or in other words, where did they click? So first, which is a vector 3, equals the mouse position. Okay, now if they are holding down the mouse button, so get mouse button, so this is get mouse button down, 0. Make sure you include the index, that would be left click. If you put like 1, it would be a different kind of click. So input get mouse button down 0. Oh, sorry, that was up here. This is input get mouse button. That's if they're holding it. Or, so anytime you use the double lines here, like a pipe, that's an or. Input get mouse button up. So what does this mean? This means first will be when they first click, and then these two are checking for, is it after they've clicked for a while? Okay, so this would be last. So I want to gather the mouse position, and then I want to recalculate my total swipe. Now you want to do this continuously, or in other words, while they are still clicking, because then you can have that movement right away instead of waiting until they release the mouse button. Then you wouldn't know like what scene you end up on. Okay, so we do that, and then after that, okay, so this is not in an if statement. We just want it to be after that every single frame. I had originally tried with the distance in mind and I realized the movement was really choppy, so I just commented that out. So after we calculate our swipe, then what we want to do is translate our main camera the opposite direction of the swipe times a certain amount of speed times time.delta time. So I did realize if you don't use the time delta time, it's just way too fast. So make sure you use that. And then after that, we'll reset our swipe. And then we're going to say first equals last. So this part right here, this is like gold. Basically, we're going to create a new starting point at that frame for the last mouse position. So in other words, let's say I'm swiping from left to right, okay? This would be my initial position and this would be my final position. But let's say in one frame, I only move that much. Then I'm going to translate based on how much I moved that frame, and I'm going to recalculate my initial position at the end. So my new initial position is right here. And the next frame, while I'm still holding down the mouse, it's going to call all these functions again, but based only on the amount I move that frame. So it'll keep doing that until I get my whole movement, and that will get a nice, smooth motion so that I can go little by little, or I can go pretty fast. And it's a really responsive, smooth motion. Okay, so that part is important, and that basically gets us moving. Just this right over here. Now you'll notice there's a little bit more in my script. In my script, if I was to stop in the middle, then it will go to the nearest plane. So how do we get it to do that? That's what you see up here. So if I am not clicking down and if I'm not holding the mouse button, okay, so it's important. This means not, exclamation point in the beginning. So if I'm not clicking down, left click, and I'm also not holding left click, okay, then what I'm going to do is I'm going to create a small loop here. I'm going to look at for each transform P in planes. So we created this array, planes, and for each we'll check all of the transforms in planes. P is a name that I've just given for this loop specifically. So the P can only be called within the loop. So for each transform P, and there are 5 transforms, it's going to do the following lines. So instead of writing this 5 times, I can just do a for each loop. It's going to find some new nearest plane, which is a float, okay? And the nearest plane is P dot position. So in other words, the position of the first transform, the second, the third, the fourth, the fifth, respectively, minus the main camera transform position. In other words, we're finding the distance between the plane and the main camera, and we're looking only at the x component, so dot x. Okay, so again, this is a float equals the x distance of the plane from the camera. And what we're going to do is we're going to do math absolute value. So in other words, if that distance of nearest plane is less than 5, and remember, this plane has a unit width of 10, so 5 would be half of that. So in other words, if we are close enough to that plane that we're guaranteed green is passing through the center of the screen, then we're going to just move it to green. Okay? So if it's less than 5, move it to that plane. And what we do to get it to move is we say vector 3 new position. So in other words, we declare a vector 3. This is a brand new one, or you can create one at start, but just declare a new one. It'll work better. Equals new vector 3, so it's kind of like we're just writing in its values. And what we're going to say is p.position.x, so this is our target for the x coordinate, but we want to keep the camera's y and z coordinates. So main cam transform position y, main cam transform position z. Okay, so we created a vector 3. This is like our goal. This is where we want the camera to be. We want it to be dead center right above the plane. But we can't just teleport it there. I mean, you could, but it's kind of sloppy. It won't look that good. You want it to be a smooth movement. So I'll show you what it looks like teleporting. Actually, this would be teleporting. You know what? I won't even show you. You can try it. It's sloppy, trust. So what we're going to do is we're going to make it move very slowly. And to do that, you have to use a lerp. Lerp stands for linear interpolation. And to do that, we're just going to say main cam transform position. So just like we're setting the position, equals vector3.lerp. So what does lerp do? Lerp will calculate a place between two vector 3's according to a float t that you give it. So main cam transform position, that's the current position of the camera. New position, that's the ideal position where we want it to be. What lerp will do is it'll find some point on the line that connects those 2 points. So where you currently are and where you want to be. And you have to feed in a float value. So what you want to feed it in is a very small number. The reason why you choose a small number is it slows down the speed. It doesn't have to be 0.05, it could be like 0.1, 0.2. Just feed it a very small number, trust me on that. And what that'll do is it will calculate 5% currently of the way between where you are and where you want to be. And every frame, it's going to move you 5% closer until essentially you're so close that it can't, move you any closer. So let's just take a look at that. I'll show you really quickly what happens when I change that value. So bam, bam, you can time it. It's pretty quick. And then if I go back to my script, let's change that to, let's say 55, okay, 0.55. So give it a second to update. Okay, so now it's updated. See how that's like instant? And then if I go to 0.05 again, save it, give it some time to update, hit play. It's a much smoother transition. So that's the power of lerp. Lerp does things smoothly. It calculates a percentage of the way and it moves you that percentage every frame. Now lerp's not perfect, but it does a pretty good job. Okay, so that was it. That was the whole script. That's if you're using a click. What about if you're using a touch? So what changes? So everything from here forward will be for, from here forward will be for a touch. So instead of using input get mouse button down, we're going to use if they have a touch count is equal to 1, or in other words, touch count represents the number of fingers touching the screen. So in this case, 1 finger is touching the screen. Then we're going to create a touch at that location, and that touch is equal to input.getTouch0. In other words, the first index of how many touches are on the screen. So if you had 3 touches, you'd have 0, 1, and 2. So we're accessing the very first touch, 0. Now, if that variable touch is in the began phase, okay, so that's what this is saying, touch.phase equals touch phase began. If it's in the began phase, or in other words, you just touch the screen, first equals touch position. Now, if it's moved or ended, then that would be last equals touch position, swipe equals that new vector, last.x minus first.x, comma 0, 0. And then what we're going to do is main cam transform translate negative swipe, speed, time delta time, swipe equals new vector 3, 0, 0, 0, first equals last. So it's the same as with our get mouse button down, same exact thing. Only thing is we're using touches. Now we also want to do this lerp function right over here to bring us back to the middle. So let's just go ahead and copy and paste some of that, maybe get rid of this extra line over there. We did the lerp in the beginning before, so we'd also want to do lerp down here. And actually, I think we don't even have to redo it. All we would have to do is change this from mouse button to get touch. So let's see, it's currently built for a mouse. If I wanted it to be built for a touch, then I would say if input touch count equals 0, then do this function. Okay, so I'm really just going to change that right there. So if it's equal to 0, then do this function, and that would make it for a touch screen. So in other words, you'd be able to drag, get somewhere off center, and it'll find the center for you. Okay, so that was it. That was the tutorial. Hope it helps. Good luck. If you have any questions, let me know. And make games. That's what I'm doing these for, so you guys can make games.